we're going to figure out how to create a motion diagram. So a motion diagram is a great way to represent a picture by using the particle model and by using our vectors for velocity and acceleration. So if I had a cart starting at point 0, and we'll say that it has some acceleration, and we'll be able to see this by the spacings of our cart getting wider and wider. We can then take our cart and represent everything in terms of particles. So we're just putting dots at the center of our cart. And these are our positions. So we label them in order 0, 1, 2, and 3. This isn't so that we know the order of motion. So now I can connect my dots. I'm going to use a green arrow. And these arrows represent the change in position, or the displacement. And because each one of these dots is equally spaced in time, we know that this also represents velocity. So we can say v0, v1, and v2. Okay. We can then also find our acceleration. Now, how do we find our acceleration? We can use our definition. And the definition for average acceleration is the change in the velocity over a change in time. And so we can look at this as v final minus v initial divided by t final, or the time final, minus the initial time. Now I can do this in vector form by looking at the difference in my velocity vectors. So I can have my start position, and I want to read these from left to right. So I'm going to do this in terms of, let's find the acceleration between velocity vectors 1 and 2. So how did I go from velocity vector 1 to velocity vector 2? What acceleration had to happen? And using our notation, we know that this is going to be v2 minus velocity 1 over the change in time. So if I'm looking at this, I want to read this from left to right. So we know that the change in time is always moving in a positive direction. And so it's going to indicate our direction, and our length in this case is going to be the change in the velocity. So I'm going to read this from left to right, and I want to look at v2. So that's what comes up first here. So I'm going to draw v2, and that's about the length. I will label my v2. And now from v2 I want to subtract v1. So v1 is pointing to the right. The negative of v1 will be flipped over, so it'll be pointing to the left. And so when I draw this, I'm going to draw v1 pointing to the left, and this is negative v1. Now to find my acceleration, we can see that I want the difference between v2 and v1. So I go from the beginning of my equation, the start of v2, I draw an arrow to the end of v1, and this is going to be representing two things. One, it'll represent the change in the velocity between vectors 1 and 2, and it'll also represent the acceleration in our motion diagram between 1 and 2. So now I can take the length of this vector, and what I want to do is draw it over, so it overlaps v1 and v2, velocity vector 1 and velocity vector 2. And this tells me that if I were to add this acceleration vector, or this change in velocity vector, to v1, I should get v2 back.